Okay, everybody, so last time we met, we finished our meeting class as an example of polymorphism. Just want to show you kind of a little bit what that looks like in our notes as well. So in there, we created the meeting class with an array of type person called the members. We also created a enhanced for loop, just to show you an example of the enhanced for loop, and the methods that went with the meeting class. We tested the meeting class in our testing class to check to make sure we could put different data types into this meeting class, and through polymorphism, they would all work out. So again, in this notes, you can see an example of an explanation of the enhanced for loop. You can find similar types of for loops in different programming languages. They allow you to write a loop without a counter variable and without knowing the beginning ending values. It's another little tool you can use in your programming toolbox. Okay, moving on today, we're today going to start looking at the concept of abstraction. And this is a big programming concept. So we're going to look at something called an abstract method and also something called an abstract class. So the whole concept of abstraction, just that word itself, is the idea of dealing with ideas rather than events. Or in other words, you deal with general things and not specific things. So in programming, abstraction is the process of hiding the details of how we implement something from a user. And it's achieved using these abstract methods, abstract classes, and something we're going to look at called an interface. So it lets you focus on what you need to do and not how you need to do it. And this is a big shift in your thinking, this idea that you focus on what needs to get done instead of the specifics of how it needs to get done. So in more specific details, in Java, an abstract class is a class which cannot be instantiated. Okay? In other words, you can define it as a class, but you can never use it to create an object. Now, this is a weird concept to think, why would I ever want to do that? Why would I want to make something abstract knowing I would never actually create an instance of it? Well, the purpose of making a class abstract is it can still act as the parent class, the base class, or the superclass for any child classes or subclasses below it. So it will never get instantiated, but the children class of it will be instantiated. Okay? So you must extend an abstract class into other classes so that its methods must be implemented. So to create an abstract class, we just put the keyword or the modifier word abstract into the signature line of the class. And once we do that, we can then create abstract methods. Okay? Same way with methods. To make a method abstract, you also add the abstract modifier keyword into the signature line of the method declaration. Now, an abstract method is an odd method. It has no code with it. So in other words, it doesn't even need curly brackets. It just ends in a semicolon, which is again strange for methods, and we'll see that in our example in a minute. The rule generally is, if you make a method abstract, then the class must be abstract. However, an abstract class can contain regular methods. They don't all have to be abstract. But if one of them is abstract, if any one method is abstract, then the class must be abstract. Abstract classes themselves can be a mixture of both abstract and non-abstract methods. Okay, so because the purpose of abstract classes was to create subclasses, the subclasses must, it is enforced that they must override and implement all the abstract methods in the superclass. The regular methods can also be overridden, but you have a choice as a programmer whether you want to override them or not. But abstract methods, the purpose of them is that you must override them. Okay? Okay. So let's put this into our example that we've been working on. We have quite a few classes already. The testing class, the computer science teacher, the doctor, the high school student, the meeting, Mr. Walks, person, student, teacher. Okay? So we're going to step away from this sort of people example, which we have been doing, and we're going to move into something else now with our abstract class. Okay? So what we're going to do is create a new class, and this class is going to be called food. Okay? Now, for this one, we do not need all the methods that our template wrote for us. So we just want to keep it simple. Just a class called food. Okay, I'll even ignore the comment for now. Okay. Food itself is an abstract concept. We don't eat food. We eat more specific things under the umbrella of food. So food itself is an abstract concept. So let's make this class abstract. Okay? So again, you see this modifier goes into the signature line of the class, meaning from this point forward, the class food cannot be instantiated. And I just want to demonstrate that right now. I'm going to save that. And let's say I was trying to do that. Food equals new food. If I tried to do that, I would get an error saying, as you can see, food is abstract, cannot be instantiated. Okay. So there's our food class. Let's put a property in here. It's going to be protected. A protected string called the group. What food group is this? Okay. Let's build a constructor for this class. Public food. And when we build it, here's what group it is. So this dot group equals group. Okay, so there we set the food group when we build a food object. And you're thinking, well, wait a minute. Why am I making a constructor? I'm never going to instantiate this thing. Well, again, we're looking for children classes. So we want children classes to possibly override this superconstructor. Okay, and then one other method, a public, this is just a regular method, void spoil. What happens when food spoils? Well, let's just do an output that when food spoils, it becomes compost, right? So that's what happens when food spoils. It becomes compost. Okay, so that's our abstract class so far. It looks in a lot of ways like a regular class at this point, except for this keyword. But the reason we need this keyword is because we're going to be adding abstract methods now. So this is a public method. We're going to add the keyword abstract. Okay, and it'll be a void method called eat. So eating food is something that needs to be done, right? That's an action of the food object. But again, this is an abstract. We don't want to say how you eat food. We just know that you have to do this. We worry about what needs to be done and not how it needs to be done. With abstract methods, we don't need the curly brackets. That's not necessary. So we end the method with a semicolon, which is a strange way to write a method, but that's what abstract methods are all about. Let's write another one. Public abstract. This one will return a Boolean, so we can define return types. Can I cook this food? Semicolon. So again, I'm not defining how this method is supposed to work, just that this is a method we have to have. Okay, there's our entire abstract class. It is a mix of 2 abstract methods and 2 regular methods, one of which is a constructor. Okay, so that's something. Now let's go and add another class to our project. New Java class. This one will be an example of food. So let's make a donut. Okay, and again, we can get rid of all the methods. We don't really need those for what we're doing here. Okay, so donut is a class that extends food. So this is what we were going for. We were making a class abstract because we knew it was going to have subclasses or children. So here's one of the children of that class. But notice, the second I put that extends food on there, NetBeans has noticed that an error needs to take place. Okay? And what happens is, with this, it says that I need to implement all the abstract methods. Okay? And I'm going to do that. This is where it enforces those 2 abstract methods down here and says, you know what? No more specifics of what needs to get done. Now you need to tell me how to get them done. So there they are right there. Eat and can cook are automatically override methods. Notice that this little icon appears because they're overrides. And it forces you to do that. So now I can define how to eat a donut. So I'll just say, okay, I like to eat them in one bite. And I'll put an exclamation point because they're delicious. And can I cook a donut? I'm going to say no, you shouldn't cook. Not that you can't, but you shouldn't. So I'm going to return false. You can't cook a donut. Now, that's pretty good, but I'm noticing still the light bulb here, okay? It's saying that, oh, and we've seen this before, if you're going to build a donut, you're going to have to match it up with this constructor. So again, the light bulb helps us with that. I'm going to add this constructor that when I construct a donut, and I know what food group donuts are in, so I'm not going to bother with this. I'm going to just send it the word that donuts are in, I don't know, donuts are in breads. It's a breads food group. And that's my whole class, okay? If I want to, I have the option still of overriding this method, the spoil method. I don't have to. Notice it's not making me override that method. It did make me override eat and can cook because they're abstract methods. That's the whole idea there. So by working with things in abstract terms, it starts enforcing sort of rules on us of the way we build up different classes. Just for fun, let's override that other method. Public void spoil. Okay, so you notice again, it recognizes that this is a override method. And let's just S out that they never spoil. Donuts are always good, even after a couple days. That's gross, but you know, come on, we all do that. All right, so there's our donut class. So we can test that. Let's make a donut. Donut equals new donut. Okay, so we now have a donut. We won't do anything with it yet, but it allows us to build a donut object right here. All right, let's make another class. New class. Let's make a banana. Okay. And we'll wipe out some of these methods. Okay, so let's do that again. Let's take our banana and have it extend as food. So again, we're going to get some help from our compiler here to do things like implement all the abstract methods and create the constructor. So right there, abstraction gives us a benefit that we can kind of speed up our process here. Oh, banana, what food group is that? Oh, that's in the fruits food group. Notice I removed the parameter here. No need. When you make a banana, it's in the superclass, or it's in the fruits, which makes a call to the super constructor, which calls it here, passes the word fruits, and assigns it to our global property right there. Okay. What else? How do we eat a banana? So you peel and eat. That's how you eat a banana. Got to peel it. Don't want to eat the peel. That's weird. Can I cook a banana? Well, of course, my mom makes delicious banana bread, so I'm going to return true. You can cook a banana. There we go. So let's take a look at that. There's our banana class. For this one, let's not bother overriding the spoil method because it's true that bananas will become compost when they spoil. So there's no need to override that method this time. It's unnecessary. All right, let's make a banana. Back to our testing class. Banana, banana, this is fun, equals new banana. Okay, we now have a donut and a banana object. All right, to test sort of how this is working, let's also apply some of the stuff we learned with polymorphism, and let's reopen our person class, one of the first classes we made in this unit. Let's reopen the person class, which as we know has a lot of nice methods in it. I'm just going to collapse them. So a constructor, a second constructor option, talk, toString, equals, clone, set, get, and that static method end of the world. And let's add a method to this class. A public void eat method, and we're going to pass it a food object as the thing we eat. Now again, here's another use of polymorphism. Eat is part of the person class, which means, since it's part of the person class, it has that ability to eat, and all of its children now have the ability to eat, which means a student and a teacher have the ability to eat. So does Mr. Walks, high school student, computer science teacher, doctor. They all have the ability to eat. And they can eat a food object. Now, we can't eat an actual food object, but we can eat children of the food object. So both donuts and bananas can be eaten by any person object. Cool. Let's write a little code for that. If that food dot can be cooked, if I can cook the food, then I'm going to take the food and eat it. If I can't eat the food, then it's going to spoil. Okay? So this is just a simple example of how that can work. That the food, if I can cook it, I will eat it. Otherwise, it's going to spoil. This method now can be put to the test back in our testing class. So let's use one of our existing people, like person, dot eat a donut. And how about Mr. Walks dot eat a banana? So these are both objects of type person, and although Mr. Walks is technically a Mr. Walks object, which is a computer science teacher, which is a teacher, which is a person, therefore it picks up that method. Banana is a food object. It's a child of food. So let's run these and let's see what the last two lines of output. Never spoil. Donuts never spoil. And bananas I can peel and eat. So all the abstraction there is coming out and working nicely. Okay? By the way, let's see what happens when Mr. Walks tries to eat a donut. Okay? It also never spoils. Okay? So donuts can't be cooked. So that's why it's doing that. Okay? When I try to eat a banana, then it's different. All right. So that was some fun just with that code there, just these different classes. But it's again showing that idea of abstraction in play. Let's take that idea of abstraction to the next level by introducing something called an interface. So an interface is the next level, which continues to look both at polymorphism and the concept of abstraction. So an interface is like a class. It's not technically a class, but it can only contain method signatures. So in other words, like abstract methods, the methods have no body to them. It can also contain properties, final properties. So if you make an interface and all the methods are just method signatures and there's no implementation, then sure, an interface is like an abstract class. It's just so that it's a little even more abstract than an abstract class because everything in it is abstract. And as a result, you don't have to put the word abstract, you put the word interface. Okay? So an interface is created using the keyword interface instead of the keyword class. Now, this means as well, you can never create an instance of an interface. Interfaces are not used to create objects. Interfaces, like abstract classes, are used like parent objects, but they're a little different. Okay? With interfaces, you don't extend them. You use the keyword implement the interface. Okay? So it's a little different that way. All right, so let's start by making a few of these. So I'm just going to close a couple of these. Don't need these. Okay? And we're going to make an interface. Right-click, new, Java, interface. Okay? So notice interface is a different option than a Java class, okay? So it's not a class in itself, the interface. It's slightly different. So let's call this interface sports. Okay? So here's what we notice about interfaces. They don't use the keyword class. They use that keyword interface instead. Okay? So within this class, I can write method signatures, not actual methods. So let's write one. When we have sports in general, we're going to make a little public void method, since it's any sport. Again, think of the idea of abstraction here, to set the home team. Set up the home team, and I'll give it the name of that home team as a parameter. So this will be a method that sets the home team. It has one parameter, the name of that home team, and that's the method itself. Again, because this is an interface, I'm not writing any method body. I'm just putting the semicolon there. Let's do the same thing for a visiting team. So just change this to visiting team. Okay? And that's it. Let's just make that our sports interface class. Well, it's not a class. It's, again, an interface. So interfaces are very simple. They don't have a lot of code in them, and the methods don't have any body to them. All right, so we'll save that. Now, nice thing about interfaces, they can also kind of work like classes. You can inherit one to the other. So we're going to do that next. We're going to right-click, make another new Java interface for a specific sport, hockey. We're going to make a hockey interface. And again, we're just making interfaces here, not classes. So the first thing we're going to do is hockey extends sports. So a hockey is a sport. This will say, okay, now since I am a sport, it will pick up these two method signatures, but let's add a few more specifics to hockey. So in hockey, we'll have a method, a void method. What happens when the home team scores a goal? Home team goal. Okay? And we don't need to define how that works. We'll just say that's something that's an action that'll need to happen. And similarly, when the visiting team scores a goal. Okay? And then finally, one last one. What happens at the end of the period in hockey? And let's give that a parameter, which period it is. So like period 1, 2, or 3. And that's our whole hockey interface. Again, interfaces are very simple. They just have method signatures, no method bodies. So now we have two interfaces, sports and hockey. One thing to note, in NetBeans, the interfaces have a slightly different icon here than classes do. Okay? Also, abstract classes have a slightly different icon than regular classes. So you can see that happening there. All right, let's make another one. Another sport. Let's make football. A football interface. Okay, so with football, let's write a couple method signatures here. So public void home team scores again. But in football, there's different amounts you can score. So I'm going to say give the amount as a parameter. Okay? Because if you get a field goal versus a touchdown, you're getting different amounts of score there. So I'm going to do that both for the home team and the visiting team. Okay? And then in football, we don't have periods, but I'm going to make a public void end of quarter method, because in football they call them quarters, and I'm going to define which quarter it is. Like, is it quarter 1, quarter 2, etc. Okay, or halftime. So there's our 3 method signatures for the football class. Okay. So that defines the interface called football. So now that we have these interfaces in play, we can use them with different classes. So let's make a class, another new Java class. Let's make, for example, a hockey player. A hockey player. Okay. So a hockey player is going to play hockey, obviously. So our hockey player class, let's let it finish. Okay. Well, what do we know about it? Well, a hockey player is a person. So I'm going to have it extends person. So it is a person. And yes, it's got these methods built in. I think for simplicity's sake, let's delete most of them, except the constructor. That might be useful. Save ourselves a little time. Let's not worry about the toString, etc. Okay, so hockey player is a person. And before we go and write all the code for what a hockey player does, we can realize that interfaces could come into play here, like this one. So another way you can think of interfaces is they are enforcing the rules of the interface itself. So you can still have inheritance here with the class, but with this you use the keyword implements. Notice it's a keyword. And then I'm going to say hockey. So the hockey player enforces the rules of this class called hockey. And the second I do that, the second I say, oh, you're going to enforce the rules of hockey, okay? That then implies that something is going on there in that class that we need to worry about, okay? Let me just take this out for a second and just say hockey player implements hockey, okay? You can see here little triangles are coming up. Whoops. Let me put it back. Extends through. That's why. This light bulb has popped up because now, like it did before, it says you need to implement all the abstract methods. And you're saying, well, wait a minute. I didn't make any abstract methods. Well, yeah, you did. Because interfaces, all the methods are by default abstract. That's why we don't write bodies to them. So it just means, oh, so I need to implement all the methods of hockey? And there they are, home team goal, visiting team goal, end of period. But notice these other two came in, set home team and set visiting team, because a hockey is a sport, so those abstract methods also became implemented as well. So look at how easy it just laid out sort of a template of the work we have to do when we create a hockey player. Okay, so we'll work on this next time. We'll wrap up here for today on our look at abstraction and interfaces.